Okay, today in this video, I want to explain what are the what the concept of the linked list. What are the concept of the linked list? What are the concept of the linked list? What are the concept of the linked list? Okay, linked list. Come to here. What are the concepts I want to cover in the linked list? Basically, okay, static memory allocation, dynamic memory allocation. What is linked list? Necessity of linked list, types of linked list. If time permits, okay, I can explain single linked list. What is the node structure and what is the dynamic? What is the self-referential structure? Okay, compilation, static memory allocation. Okay, actually the program compiler, any programming language compiler will have the two process. Two process. The first pass is compilation. Compilation. Second pass is execution. Okay, compilation means gathering the requirements. Suppose if you want to write a program, okay, first of all, what are the requirements you need? What are the requirements you need? That's very, very important. Okay, suppose if you want to write the addition of two numbers, you need two variables. Okay, you need two variables. Okay, fine. Here I want to explain. Okay, here n is a variable, n is the integer variable. It requires 2 bytes of memory. Basically, in programming language, while writing the program, always you have to concentrate on, okay, what is the n here? N is an integer variable. That's all. Actually, the meaning of n is, okay, we cannot concentrate. What is the meaning of int n means? Okay, n is an integer variable. Suppose this is a high level statement. N is an integer variable is high level statement. At low level, what's the meaning of int n means? N is the integer type means what is the meaning of the statement? The meaning of the statement int n is allocating the 2 bytes of memory for integer in the RAM. Allocating the 2 bytes of memory, whatever the variable, integer variable, that is 2 bytes of memory has allocated. The 2 bytes of memory has identified by the variable n. Here, that is the reason n is called as identifier. Okay, n is called as identifier. Very simple. Okay, why it is called as suppose the person. Suppose you have to find out a person. How can you find out the person? Person is an object. Okay, that object having the name. That name is called as an identifier. Here, 2 bytes of memory in the memory. 2 bytes of memory. 2 locations in the memory. The 2 bytes are identified in the programming language in the program by using the identifier. That is called as n is an identifier. Not only n here, any variable. Okay, the memory has allocated yet compilation. It is called as static memory allocation. Suppose if you want to construct a home, first of all you have to gather the requirements. That is the area and what is the place and also what are the requirements for our bricks, iron, sand, like this, manpower. All you have to gather first. Then you can start the construction. Not only here, wherever, whatever the work in the nature, having the two passes. The first pass is procuring the or gathering the requirements. The second pass, what are the requirements already you gathered? Those requirements you have to utilize in the execution. This is the program. First, gathering the requirements. These requirements you can utilize in the execution. Okay, here, suppose the memory has allocated a compilation, it is called as static memory allocation. Okay, then you will come to, I will write a small program, addition of two numbers, okay, in C language. Okay, what is the meaning of? Okay, here I have the two variables, A and B. A and B are identifiers here. A is equal to 10. A is equal to 10 means what is the meaning of A is equal to 10? Initialize the 10 to variable A. Initialize the 20 to B. Here 10 and 20 are identified by the 10 is identified by the A, 20 is identified by the B because of A and B are identifiers. Because of A and B are identifiers. These two are the executable statements. Whenever the same program we can run, okay, in the turbo compiler, first write this program, then you can press the F7 key for to trace the program. First it will shows the line, the trace line. with it started with void main. Once again, you can press the tracer, that is the F7. Okay, it will goes to the this statement, but it cannot be shown this line. Reason, this is the compile time statement. The program having the only two types of statements: compile time statements and runtime statements. All declarations are compile time statements. If compile time statement means if have the memory, then that memory you can process in the execution. If you don't have the memory, how can you process? Suppose if you don't have the A, how can you store that 10? Think like that. If you don't have the A, how can you store the 10? Where you can store? You cannot store. That is the reason here I have two variables A and B. Okay, here I have A and B. A is equal to 10, B is equal to 20. Initialize 20 to B. Okay, right. A is equal to 10, B is equal to 20. Two variables here. A is equal to 10, B is equal to 20. A have the 10, B have the 20. Okay, the next line will show A is equal to 10 means already A having a 2 bytes of memory in the memory. Okay, the compiler will takes place of, okay, what is the value of, that is a right hand side, that is assigned to A. What is the right hand side here? 10. That 10 has copied into, is loaded into variable A. Variable A, that's a high level statement. Actually, what is the meaning of the statement? 10 is stored into the already allocated memory, that is called as execution. I hope all of you understood. Here, what are the requirements here? A and B are requirements. A and B are two identifiers. Already 2 bytes of memory for A, for B, already allocated at compilation. While running the program, the 10 has assigned to A. The 10 has assigned to A means where it has assigned in the program. Actually, where is the value of A? The value of A means A is at memory. Okay, the value has stored in the memory allocated for A. At the same time, B is equal to 20. The 20 is assigned to A means the 20 is stored into the where the memory is allocated for B. Okay, that is the meaning of A is equal to 10 and B is equal to 20. That means before running the program, before executing the program, already you have the requirements. Those requirements are, okay, already allocated in the memory. That is called as static memory allocation. I hope all of you understood what is the meaning of the static memory allocation. At compilation, the memory has allocated. It is called as compiled memory allocation. That is static memory allocation. Compiled memory allocation is called as static memory allocation. Then, what are the problem is with static memory allocation? Problem with static memory allocation. Okay, suppose I have to declare, suppose int a of 100, int a of 100. Okay, here how many number of integers? 100 integers. 100 integers are allocated sequentially. What is what is the meaning of int a of 100? 100 variables here. 100 variables, 100 integers are grouping together. A of 0 to A of 99. Okay, A of 0 to A of 99. Here, this is a compiled memory allocation. That means 200 into 2 means 200 bytes of memory has allocated sequentially. That is in the memory. That is called as meaning of int A of 100. Suppose 100 bytes are actually here 200 bytes are allocated. Just have to use 10 bytes of memory. Total how many number of bytes are allocated here? 200 bytes of memory has allocated, but utilize only 10 bytes of memory. Remaining 190 bytes are wasted. You cannot adjust the remaining 190 bytes to some other variables. You cannot adjust. That is the disadvantage of static memory allocation. You can allocate, you can hold the memory, but you cannot release. You can hold the memory, but you cannot release the memory. That is the disadvantage of static memory allocation. Okay, why do you go for this is the dynamic memory allocation? This is only the reason we cannot modify the base address of array. Okay, the concept here, why that suppose here you have that 190 bytes of free memory as per the I did not utilize in my program, but I cannot allocate the 190 bytes of memory to some other variables in my program. Even suppose, because even the some of the variables lack of memory, it cannot be adjusted. Okay, it cannot be adjusted at the time of C compiler. Okay, at the time of C compiler has introduced, okay, the memory locations, the size of the RAM is 1 MB. The size of the RAM is 1 MB. That means in the 1 MB and 1 MB of memory, the operating system has loaded. At the same time, programs are loaded in the same memory, and also what is the data, what is the extra stack, all have to be allocated in the same one memory, one MB of memory. That's a problem with the C compiler, because of while developing the C compiler, that's a problem. The size of the memory is very less in say 1970s. The size of the RAM is very less. Okay, due to that, you can utilize the memory efficiently. If you have the less resources, we can apply the efficient algorithms. If we have the less resources, we can apply the efficient algorithms. If we have the more resources, okay, no need to apply the efficient algorithms. If you have more requirements also, we can apply the efficient algorithms, but here the resource is memory. If you have the less memory, then okay, this kind of situations we can arise, then we can solve. That means 190 bytes of memory has free wasted here, means we can adjust the 190 bytes to some other application also, some other variables also, but in the static memory allocation it cannot be done. Once allocate, it cannot be done, even you can utilize or not. Okay, enter your program, you cannot utilize what is the leftover memory, what is the unused memory in any array. That unused memory is not assigned to any other variables because of static memory allocation. Because of memory allocation means just it has to be allocated, but it cannot be free, it cannot be released. Suppose here we can assume a base address is, suppose the a 200 bytes are allocated in the memory, means where it has to be. Actually the array size, actually the segment, the compiler will divide the memory into segments. Okay, one segment size is 64 KB. One segment size is 64 KB. Okay, in the 64 KB, 200 bytes of memory has allocated. 64 KB means starting with 0, every 64 KB means 65,536 locations. Total how much memory here? 65,536 bytes of memory. Okay, the starting byte address is 0. Okay, the starting byte address is 0 and ending byte address is 0 to 65,535. Okay, 65,535. Okay, this is the range of this segment, 0 to 65,535. Among these values, 200 bytes are allocated. Okay, in anywhere 0 to 65,000 locations are there, 200 bytes are allocated from anywhere. That is called as random access memory. Random access memory means 200 bytes are allocated for my variable array variable a, means 200 bytes are allocated from 0 to 65,535 within the boundaries. Okay, somewhere it has to be allocated. That means randomly one of the position from 0 to 65,535, one of the position has randomly selected. Suppose you can assume that is 2000. Randomly selected from there, suppose 2001, randomly selected from there, sequentially 200 bytes are allocated. 2001 to 2200. Okay, what's the starting byte for A 2001? From there, 200 bytes are sequential allocated. Okay, this is very important. Randomly selected the location. From there, sequentially the memory has allocated. This is very important point. Randomly 200 bytes are here. The randomly selected location is 2001. Okay, that's the location from that byte to. Okay, what is the ending byte? 2200. 200 bytes are allocated from there. 2000, 2001, 2002, 2003, 2004, like this. Like this. Suppose here A means A of 0. Okay, I will tell you what are the how to calculate the values here. How to calculate the addresses here? Okay, come to 200. What is the starting byte? Suppose, okay, I will take this one as a 2000 for easy to. What's the last value? 2199. Okay, just started with 0 means one of the value has decreasing from 2200, that is 2199. A of 0 means A means 2000, of 0 means 2000 of 0. How can you calculate this one? 2000 plus what is the subscript here? 0 into, okay, the size of the data type. Size of the data type. Here 2000. Okay, then we will come to, okay, the next step. Okay, 2000 plus 0 into what kind of array it is? It is an integer array. How many bytes for integer array? 2 bytes. How many bytes for integer array? 2 bytes. Okay, finally 0 into 2. This is equal to 2000 plus 0 is equal to 2000. That means where it is located, the A of 0 is located at 2000. How many bytes? 2000 and 2001 is reserved for. What are the addresses of A of 0? 2000 and 2001. 2 bytes are allocated. Then I will calculate A of 1. Same, A means 2000 of 1. Okay, then you will write it 2000 plus 1 into index value into size of the data type is 2. Now this is 2002 as per the formula. Size of the data type, it is an integer array. The size of integer is 2 types, that is 2002. A of 1 address is, what are the locations for A of 1? A of 1 is located at 2002 and 2003. Okay, like this you have to calculate the remaining addresses. Okay, this is for one dimensional array address calculations. Okay, then what is the problem with the static memory allocation? Already explained. Once you can release, once you can hold, you cannot release. You cannot release the memory. Throughout your program, what is the address of A means 2000. This is very simple. Throughout your program, what is the address of A? Okay, it is called as displacement. What is the 0, 1, 2 like this? This is the displacement. Okay, I am starting from 2000. What is our displacement? If it is 0, 2000. If it is 1, 2000 plus 1. 2000 plus 1 means 2002. What is the starting displacement is 1 here. Suppose for next variable, displacement is 2, 2000 plus 2. That is 2000 plus 2 into 2 because of integer array. If it is a floating point variable, 2 into 4 is equal to 2008. Sorry. Throughout your program, the address of array, throughout your program, the address of array is the 2000. It cannot be modified. It cannot be modified. Just you have to addressing the displacements. The starting displacement is 0. The ending displacement is 199. Suppose I have to calculate A of 199. Okay, what is the base address of array? 2000. Okay, plus 199 into size of the data type is equal to 199. 199. Totally 100 elements. Okay, this is, look here, 2000 plus 99 into 2 is equal to 198. Okay, this is the 2198 is the address of the A of 99. 2198 is the address of the A of 99 locations are, A of 99 locations are 2198 and 2199. Okay, for whatever the address you want to calculate, the displacement, what is the base address of array along with what is the displacement? Okay, along with what is the displacement? Displacement followed by displacement into what's the size of the data type. Here, what is the static memory allocation? It cannot be. Release the memory means simple. Suppose I will write it A is equal to A plus 1. Actually, you know what is the A value here? We will come to right hand side. What is the A value here? The base address of A is, it's not a value. Okay, it is not a. I will show you clearly. I will show you 2000. A means, okay, here in the previous example, A is substituted with, what is the A value substituted? A is substituted with the where it has started. At 2000, the array has started. That is 2000. Okay, plus 1 means that is assigned to A if it is accepted. No need of dynamic memory allocation. Suppose 2000 plus 1 means, as per address calculations, what is the value 2000 plus 1? 2000. 2002 is assigned to A means address has released. Address has released. A basically 2000. A is equal to A plus 1 is. After A plus 1, 2002 got it to 2002. That is assigned to A means previously what is the A value? 2000. What's the address of A? 2000. After address of the A plus 1 is 2002. That is assigned to A. Now A is 2002 means 2000 has released. 2000 has released, but it is not accepted. But in C language, it is not accepted. That's a problem with the static memory allocation. That is the reason we'll go to dynamic memory allocation. Okay, suppose I want to show one thing I want to show here. Okay, come to here. I have a look here. This is 2000. Okay, this is 2001. These are the two locations in TN. In TN having the 2 bytes of memory. The starting address is 2000. The next byte address is 2001. Initially, here have the suppose this is an address. This is also an address. This is called as here you have to store the values. You can change the values here. You can change the values. It's possible. If you want to change, it's possible. But you cannot modify the addresses. You cannot modify the addresses because of addresses are fixed. Addresses are fixed locations, fixed values. But what are the values you can store here in the addresses? Addresses, the values are modified. The values are modified. Okay, what is the concept of dynamic memory allocation? The addresses are also stored as a values. The addresses are also stored as values. The problem has solved. Suppose here I have the 2000. Okay, in the value place, suppose consider this is also 2000. Suppose here I have the address 3000. I have to modify 3000. 3000 is also address, but address is in the value position. Address is in the value position means you have to modify. You can get the address into the value position. You have to modify. That's a concept of pointer. Takes the address into the value. Okay, here ampersand n means 2000. Ampersand n means 2000. What is the value of ampersand n? 2000. N means 3000. I hope all of you understand what's the meaning. Okay, n is equal to 30. Address of n is 2000 and n is equal to 30. Directly you can write the value. It is called as, you can write the variable, you will get the value. This is value. Okay, this is address. This is the value, this is the address. Okay, I think this is the way, this is the reason. Okay, you cannot modify the addresses. If you can modify the addresses, no need of pointers, no need of dynamic memory allocation. Okay, no need of dynamic memory allocation. Come to here, n is equal to 30. Here, the value of n is equal to 30. Suppose if it is an address, if it is an address, the address is in the value place means that's also value. Here, no differentiation, no difference between it is a value, it is an address. Both are the values. The values are 0 to 65,535 means 0 to 65,535 is also, it is also value. Okay, it is also value 0 to 65,535. Suppose the 0 at before the variable name, that's called as an address. Inside the variable, it is called as a value. Okay, it is called as a value. Now I will explain what is the pointer concept here. Int star p, just the introduction of the pointer. Int star p. What is a pointer? Pointer is a variable which holds the address. Pointer is a variable which holds the address. Suppose I want to display the number. Okay, I want to read the value, I want to display the number. Okay, simply I will write the program by using the pointers. Okay, address is a variable which holds the address of other variables. It's not a correct definition. Address is a pointer is a variable which holds the address. That's all. No need of another variable. Another variable address is stored in the pointer means what is the necessity of another variable is another variable is the problem. Here another variable is the problem. You can declare another variable is the problem. Suppose I have to declare int a of 10,000. Int a of 10,000 means 2,000 bytes are allocated. Suppose you can assume int a of 10,000, s of 10,000, 2,000 bytes are allocated. 2,000 bytes are allocated. Now I have to write it int star p means this is the pointer p is equal to a means address of a means this is not a pointer concept. This is also pointer. I accepted, but for this purpose the pointers are not introduced. Okay, here I have to declare one pointer int star p pointer. Okay, now printf read the value, enter value. I don't have one more variable. I don't need one more variable. Scanf percentage d comma p. Printf percentage d comma star p. I will explain how it will works. Okay, come to what is the p here. Okay, here this is the pointer p. Pointer will also having the address. It's a static allocation. Into star p means that's a static memory. 2 bytes are allocated for pointer variable. Here 2 bytes are 2000 and 2001. Okay, in the previous I explained scan a percentage the p. P means what is the p here? What is the p here? Simple. Suppose actually in the scanf statement you have to write the ampersand p. But here you don't write the p. P means suppose p means what is the value here? Okay, p means what is the value here? Here having the address. Okay, here having the address. Suppose before going to this one, I have to allocate the memory. No memory here. P is equal to okay malloc. This is the dynamic memory allocation function. Malloc of 2 bytes. 2 bytes are allocated. The starting byte is 2000. Okay, starting byte is 2000. 2 bytes are allocated. Okay, the starting byte address is stored in the pointer. Sorry. Here, this is the starting byte address. Suppose you can assume this is 3000. Okay, pointer variable p is at 2000 in the memory. P is equal to malloc 2 bytes means another 2 bytes. Okay, I have one more 2 bytes allocated. One more 2 bytes are allocated starting from 3000. 3000 and 3001. 2 bytes are allocated. 3000 here. Okay, 3000, 3000, 2 bytes are allocated. The 3000 is stored at the starting byte of the P. Starting byte of the P. Now, what is 3000 here? This is the address. P is equal to malloc size of struct node means 2 bytes are allocated. The starting byte address is stored in the pointer variable. Okay, that's in the P. Now we can write it, enter a value. Okay, I said that simply you can write the variable name. Enter a value, variable name means what is the value in P? What is the value in here? 2000. This is the P variable. Okay, this is the P variable. What is the value in P? 3000. Now we can enter value. What is P? P has replaced with 3000. Now I can enter the value. That value has stored into the 3000. Okay, that value has stored into the 2000. Suppose I have entered there. What is the value I have given here? What is the value given in the at a runtime? Okay, while executing the scanf. Okay, what is the value? Scanf percentage P means what is the P? P means 3000. Now I can enter the value that is stored at 3000. Okay, that is stored at 3000. And suppose you have to left this is no need of this one. Don't confuse. The starting byte is enough. Right, 2000, 3000 having the value. Where is 3000? 3000 is in the pointer. Okay, 3000 is the pointer. Where is the another variable here? I don't have another variable here. This is the concept of dynamic memory allocation. After some time, okay, now I can write it. P is equal to free of P. Free of P. Free of P means what is the P? 3000. Here it is not free of P means, okay, just copy. There is no 3000 here. Dynamically the memory has allocated and also release. This is called as dynamic memory allocation. The memory has allocated at runtime. Because of this is the runtime statement. This is the runtime statement. P is equal to malloc size of struct node. Sorry, P is equal to malloc 2 bytes. 2 bytes are allocated. 2 bytes are once you have to allocate 2 bytes. Okay, after your work has finished, you have to release that memory. You have to release that memory means some other variable can access that memory in your program. Hold and release. Just hold the memory, just release the memory by using pointer. Simple concept here. The pointer means simple, very simple. Okay, the pointer, what is the necessity of pointer means? Here the pointer is also variable which holds the address. Address is in the part of value. You have to modify that value. Address is the part of the value is part of address. It cannot be modified. The address is a part of the address. We cannot modify. Both are the values. 2000 is the value. 3000 is also value. But 3000 here you cannot modify. Okay, 3000 you cannot modify. You have to allocate 3000. Okay, you cannot modify this 3000. The 3000, if you want to modify 3000, you have to keep here. Now I can write it P plus plus, it becomes 3002. Okay, P is equal to 3000. Suppose I have to write it P plus plus is equal to P plus 1, it becomes 3002 because of the address is at value position, the part of value. Okay, the part of value. This is the advantage of the dynamic memory allocation. Okay, this is the advantage of the dynamic memory allocation. Without dynamic memory allocation, okay, you can get some kind of problems. That means lack of memory. Okay, lack of memory. Most of the cases in the nature, we can follow the static. Very rare we can follow the dynamic. Okay, in nature, not in program language. Nowadays, no program language having the pointers. Nowadays, no program language having the pointers. Pointers are designed for in C language only for dynamic memory allocation. Dynamic memory allocation. Okay, then. Next, coming to the next concept is, okay, what is linked list? Before going to linked list, already in this class I explained what is an array. Array is a homogeneous collection of values. Homogeneous collection of values. Homogeneous collection. Homogeneous collection. Okay, suppose what is an array? Homogeneous collection of values is called as array. What's the problem with array? Suppose here int a of 100. Suppose I want to delete. Suppose you cannot release the memory, means how can you delete the location? This is a static. Arrays are introduced. Arrays are declared with the help of static memory allocation. If you want to allocate the memory, you cannot release that memory. You cannot release that memory. That's the problem with arrays. Suppose if you want to delete the element means, okay, then you have to adjust the array. Suppose I have array 10, 20, 30, 40, 50. Okay, suppose I want to delete 40. Okay, total 5 elements. Suppose it is the 5. Total 5 elements 10, 20, 30, 40, 50. I want to delete 40. First, you have to search the 40. Okay, once you can find, then the output array have the 10, 20, 30, 40. That's all. Sorry, so not so 40, 50. The next location also have the 50. The next location also have the 50. You can adjust. But here 40 is deleted means you have to show the value has deleted. You can write your own logic to show the 40 has deleted here. But in the dynamic memory allocation, in the linked list, if you want to delete a node, you have to delete that node from the sequence. You have to delete that node. No need of adjustments. No need of adjusting the values. Just adjusting the addresses. Here values are adjusted. Actually, the fourth position having the 40. After, if you want to show 40 has deleted means just you have to move the 50, okay, at the place of 40. You can say this is the, that means adjusting the values here. But in the linked list, adjusting the addresses. You cannot adjust the values. So addresses here. This is 2000, 2001, 2002. This is 2004 at location at 2006. This is at 2008. 2006 location element is deleted means 2006 location is not deleted. 2006, what is the value? That value has adjusted with 2008 value. I will show with the diagram. Okay, this is 2000, 2006 and 2008. Here have the values 10, 20, 30, 40 and 50. This is a of 0. This is a of 0. Okay, this is a of 1. This is a of 2. This is a of 3. Okay, this is a of 4. A of 0 address is 2000. A of 0 value is 10. A of 1 address is 2000. Like that, A of 4 value is 50. Address is 2008. Suppose if you want to delete this location is not deleted because of that is static memory allocation. This location is not deleted. You have to adjust the 2008 location value that has to be adjusted. This has to be adjusted to here. Here itself also 50. But you have to show from 0 to 3 only. You have to show the values 0 to 3 only. What is the fourth value? Fourth value has adjusted to. Value has adjusted to before position. Whenever you have to find the 40 here, just what are the remaining elements after 40 are moving backward, moving forward, not backward, moving forward. Suppose 50 after, if you have the 60, then you have to move 50 at 40 position, 60 at 50 position. At back of 60 having one more 60, but you have to show from 0 to 3 only. For I is equal to 0, I is less than 3 only. I is less than or equal to 3 only. Just you have to adjust. Values are adjusted here, but addresses are not adjusted. You cannot remove this location because of this is the static memory allocation. Just you have to adjust. If you want to delete this 40, okay, here delete. Just you have to adjust here the 50. You have one more 50 at 2008, but you have to show from 0 to 3 only. This portion of values only. Because of fifth position, I have already detailed the fifth position value has adjusted to the fourth position value. Like this, you have to write it in arrays. The array, how can you delete the array? How can you delete the element from the array means this is the procedure. But in the linked list, okay, this is the one node. The node is 2006 means you can delete the node with address. Addresses are adjusted. Addresses are adjusted. That is called as linked list. You can delete permanently, you can delete. But here the values are not permanently deleted from the memory. Here 50, 40 is deleted means okay, fine, 40 is deleted. That 50 is also duplicated here. 50 is duplicated here, but you cannot show two 50s. For I is equal to 0, I is less than or equal to 3 only. Okay, that is the reason we'll go for dynamic. That is dynamic with the dynamic memory allocation with linked lists. Okay, dynamic memory allocation with linked lists. Okay, next one. What is the next topic? Necessity of linked lists. Okay, necessity of linked list means just now I explained what is the necessity. You have to insert. Suppose here having 40. If you want to insert, okay, between the 10 and 20, if you want to insert the value, you can write your own logic. You can write your own logic. That means in between 10 and 20 means, okay, here you have to insert 15. Okay, we'll take one more. Okay, all you have to move down. Okay, here you have to insert 15. That means for this, what I done here, for this you have to write the code. For this you have to write for deletions and insertions. You need to write your own code. In the dynamic memory allocation, the linked list also you have to write the code, but adjust the nodes. Just adjust the nodes. If you want to remove, just you have to remove. One of the main important arrays to linked lists are not in sequential. The first node is at one location, the second node is at some other location, third node is at some other location, fourth node is at some other location. But here, all the elements in array in sequential order. This is the main difference between the arrays and linked list. The array elements are contiguous, that means sequential order. The elements array locations are sequential, but linked list locations, the node locations are not sequential. The linked list node locations are not sequential. This is the main difference. Okay, this is the main difference between the single linked list and arrays. Okay, if you want to insert the values in linked list, addresses are adjusted. Node 1 and node 2. In between, I have to insert. Okay, in between, one more node has created, just adjusting the addresses. Adjusting the address. Here, if you want to insert in between 10 and 20, if you want to insert 15, you have to adjust the values. In the sequence, here the indexes are, what are the indexes here? 0, 1, 2, 3, 4, like this, 5. But in the linked list, the nodes are not in sequential. Node is sequential, but nodes are not sequential. Okay, one node is at 2000, another node is at 3000, another node is at 4000, okay, another node is at 50. Just you have to give the links from 2000 node to 3000 node, 3000 node to 4000, 4000 node to 5000 node. The nodes are not at all sequential. 2000 node 2000 is in one location in the RAM, another node address is in 3000 in the RAM. Okay, different locations are there. Different locations the nodes are stored. Okay, that's a necessity here. You have to delete the elements, you have to insert the elements wherever in the linked list, adjusting the pointers, and you can apply. That is the necessity. Okay, necessity means you can allocate the memory, and also you have to delete the memory. Node has inserted, node has deleted. You can write, you can do any kind of operations on the linked list. Okay, the database you have to create with the linked list. You can access the elements. Okay, and then in sequential order, all the nodes, okay, you can keep in sequential order. Like that. The necessity of linked list. Next one, types of linked lists. Types of linked list. Here we have three types of linked list: single, double, single linked list, double linked list, and the third one is circular list. Circular list. Three types of linked list. Single linked list. What is the node structure in single linked list? Okay, what is the node structure in the single linked list? Okay, I will show what is the node structure. Okay, this is the okay, the node structure here. Very simple. Single linked list node. This is the node structure. This is the data field. Okay, this is the link field. Okay, data field and link field. This is data means whatever the data, either into primitive data or primary primitive data or non-primitive data. Non-primitive data means you have to keep here structure variable, you have to keep the string here, whatever the non-primitive. Non-primitive means arrays, structures, unions, files. Okay, these are the non-primitive data types here. Okay, here data. Link means this is the next node address. Link field have the next node address. Means, okay, the first one is this is the data, any kind of data, but the link field should be pointer. Okay, the link field should be pointer. Next, we will come to take the one more node. Okay, this is also having the data and this one link. Okay, just you have to connect the two nodes. Now this is 2010. The starting node address is, okay, I will tell you. This is 20. This node address is, there is no one more node. Just you have to write it now. Okay, here the starting node address is 2000. Which is the starting node address here? 2000. This node address is 2000. This node address link field. This node link field have the next node address. This is 3000 node. this is 3000 node. Okay, the second node address is first node link field. The first node link field has the next node address. Suppose if you have one more node, just you have to write it. That is, suppose you can assume the address is 4000 here. The third node address is 4000. Then this is 4000. Okay, here have the 30 and the last node. If there is no extension means simply you can say this is the null. Okay, just you have to make a connection between these two. Okay, now this node address is 4000. Okay, this node address is 4000. Okay, this is the single linked list. Okay, the starting node address and first starting node address link field having the next node address. Okay, the second node link field having the third node address. Okay, like this until which is the last node link field have the null. Because of the reason is simple, there is no extension. Okay, the linked list has ended there. No more nodes are connected. Okay, from this node. Okay, which node having the null means in the single linked list, the last node having the null. Okay, the last node having the null. Okay, that's the concept of the single linked list. You have to apply different operations. Okay, here you have to apply different operations on the linked list. First, how to create the linked list? What are the operations here? Create. Next one. Okay, display. How to display the linked list nodes and count how many number of nodes and such element in the node in the list. Next one, add it begin. Already I have the list. Okay, before that list, one more node will have, I want to add it begin, add it end, and reverse the linked list and delete at begin or delete at begin and delete at end, delete at wherever, delete at position, any position, delete at any position. Okay, these are the different types of operations you have to apply in single linked list. Not only in single linked list, in double linked list also, circular linked list also we have to follow the same. Okay, we have to follow the same kind of operations. Okay, same kind of operations. Okay, fine. Okay, in the next video, okay, I will go to the how can you insert, how can you create the linked list and what are the remaining operations here. Display, how to count, how to search, add it begin, add it end, reverse, delete it begin, delete at any position. Okay, one by one I will explain, and in the next video we will continue the remaining. Okay, bye.